see a robot. Where's the owner? Al.
It's very cute.
It's Cutie.
Yes.
I'm Al Margolis. Trying to be fast. Normally my robots don't have names, but my wife started calling the thing Cutie for some reason, and that is sticking.
That's what the box says, dude.
Am I up on the screen? All right. So I took 2 classes in Ross and decided I'd rather write my own than than finish that process. So this is running a thing called VNavs, which borrows concepts from Ross, but is just a totally different, unique code set. But my goal is to build an alternative to Ross, a general robot operating system. Hopefully by challenge 3, I will have 3 robots running identical code with very different hardware. I try to come every meeting and do a little show and tell and have a new feature, because if I didn't have that sort of deadline, nothing would get done. What you're seeing up on the screen is my mission control. That is confusing a second. Okay, so you're seeing what the camera sees, so I can point that out to the audience, and there you all are in real time. So I can see what the robot is seeing. I can display sensors. I've got my GPS. At the end here, I'm debugging I created a PID object. This is all written in Python, which isn't working yet, so I can just display in real time the PID accumulators, errors, and to help debug dynamically. The big 2 things that are kind of interesting to me is I'm not really running the robot much because I broke it today while working on other things. This is my portable mission control, which runs that same program. It's got a Raspberry Pi in it, but also gives me the ability to run back and forth manually when I want to do that. This is actually about 3 generations back in software, but because of the messaging protocol, it can still drive the robot. What I am working, my goal is for there to be just one set of software that doesn't have to be fiddled with all the time. And this is what I want to show today. I've just gotten this kind of working, but not well enough. But this is my Navigator scripting language. So from, I load a text file, on my MacBook or from the portable and say, run this mission. It sends that to the robot, and the same core code, with some luck, come June, it'll be the same robot, the same operating system running Robo Magellan and line following. I'll bring my duct tape, and all I'll do is load in a different mission. And I've been working kind of that way, but not fully implemented for a long time. I've now added stages, which essentially give me subroutines now within the scripting language. And what I can't demo for you today is I've got it. I start it. That will, initialize the robot, bring up the screen, and let me point at the line I want it to follow. One of the great challenges with all of this is color matching. I point where I want it to start. It will analyze the colors in that area and start to say that's the color of the line and follow that line. And same sort of logic for cones during the setup phase. And then run, and again I will be able to have a whole bunch of capabilities that can be modified on the fly just by changing this text fly, downloading it, and go. And I've got a graphics processor that works the same way. One of my frustrations, one of the things I do in competitions, if you're ever competing and I'm in the audience, when your robot does something stupid, I'm the guy who walks up and says, what went wrong? And an amazing amount of time is I don't know, and I don't know how I'm going to figure it out. One of the big things this system does is forensics. Again, almost working, but not quite demoable. Every image is saved to a file. Every message going from all of these among the nodes goes to a file. Everything's got a timestamp. And soon I'll be able to go back to mission control after mission and say, replay the mission, and be able to go frame by frame, see what the robot saw, see what its sensors were reading, and looking at the output that it sends of how it made its decisions. So on the line following, when the robot decides to turn left by X amount, it's also showing the error. The three elements: the current error, the integral, and the differential. So if that function isn't working well, and the current constants. And so eventually I'll even be able to replay and try different scenarios. So that's it if anybody wants to look at it later on.
Nice.
Otherwise, the next person can take over.
And what are you calling the software?
VNavs. It's Visual Navigation System. It started competing in the DIY robotics line following thing.
Oh.
But anything I touch, if you told me to build a hammer, it would end up being a software device. That's kind of. Yes.
Comment on a question. Putting the debugging in there is wonderful. The proof of the design is in the debugging.
Absolutely.
And the scripting language, that's your homebrew language?
Yes.
Okay, just curious. Good.
Nice.
Yeah, I'm the king of not invented here on this project.
You're using OpenCV in there, right?
Everything runs Linux. It also can all run on OS X. Conceivably could run on Windows, but I don't have any of those computers to test. All of my code is Python, OpenCV, and just a whole bunch of other things as needed.
Nice.